Hi, this is Greg Tavares, and welcome back to Lesson 4 of using vertexshaderart and GLSL for creative coding. Starting off where we left off, I'm going to delete these time adjustments that I put in before, just to keep it simple, and because this lesson is going to be about using sound. So the first thing you need to know, well, okay, like before, let's comment out some of the motion, just to make it easier to see what's going on. So almost all the motion's out. We still have some motion here and some motion here. There we go. We have nothing now. Back to a grid. All right, so the first thing to do is that you can post, well, basically most SoundCloud URLs you can put in here. SoundCloud URLs to a particular song or playlist. It's up to the artists themselves whether they allow you to use the song outside of SoundCloud, so some don't. You have to try a new one. But I'm going to go over here and use one that I know works at the time I made this video. So I go to SoundCloud, and I'm going to search for Bojeru or Bojero. And he has a song that I kind of liked called, well, I don't know, it's Fly by Light. So I'm going to copy this URL and paste it in here. And if we're lucky, it should start playing. All right, it's playing. Turn it down a little bit so you can hear me. So the first thing to notice is that if you go over here to help, there's this thing called a sound texture, and that is basically analyzing the music, putting it in a texture. So here it is. The very bottom line is the current music, and then it scrolls like in history for up to four seconds. And you can see that here. If you look at help again, it says that the sound is, right, it's a sampler 2D, which means it's a texture. It has data from the music, only alpha, 240 rows of history. So that's 4 seconds at 60 frames a second. If your computer's not running at 60 frames a second, well, then it's going to be more or less history. Like if someone running at 30 frames a second, then you're going to have, 8 seconds of history. In any case, to pull data out of that, the easiest way is to do something like, let's say the sound is from a texture, which is the sound texture, and then we have to give it a texture coordinate. So we'll say, well, let's say U goes across the texture, and we'll just say right at the beginning of the texture. And then we only need the alpha channel. Let's put it on the value. Now that is line 0 going across, line 0 of the texture going across, line 0 of the texture going across the whole thing. So if we put V here, we're basically getting that exact same texture. If we crank up this resolution, well, we need to be able to see it, which is hard to see. Set the size to larger, and then we can go like this, and we can see, right, it looks very much like that one texture, except since we're going through this sound, through this color code, it's coming out red. So what else can we use it for? Let's change this, and let's use it for the point size, right? Let's set, well, Let's set that back to that. Let's set this back to 15. Let's set this back to a reasonable number like 1,000. 1,000. And let's make the point size be, instead of just 15, let's make it sound times 30. Now you can see they change based on their volume. Now what I find is that if I go back here to help and we look at the way, well, first of all, you click over here, look, there's nothing going on over here. Go back to help and you click wave. You can see the wave here, and you can see there's nothing out here. That's probably because the MP3 compression that put it online stripped out all the high stuff. This red part goes from 0 to 1 across the texture. This green one is from 0 to 0.5. This bluish one, or aquamarine, or whatever color that is, goes from 0 to 0.25. And the purple one goes from 0 to 1.25. So this is basically the full thing, half, quarter, 1/8. And I find that most of the action happens in the first quarter or the first 1/8. So we can use just the first 1/8 by just multiplying this by 0.158, and we just get the first, wrong side. We can use that by just multiplying U by the first eighth. Now you can see we're getting a lot more detail. What I also find is like this is the whole history, right? 4 seconds, 1001, 1002, 1003, right? I find that's too much for most things. So I'm going to set this to also 0.25. And now we're getting just a second, 1001, right? It's a little bit faster and a little bit more peppy. Another thing is I feel we need more impact. And so I usually do that by using the power function. So power takes a value to a power. So if I go pow, and I set this to 5, what happens is if you ever look at a graph of power, like 0 to 1 would go like this, but power of 0 to 1 would go like this, across, then shoot up. So it basically says keep it low until it gets to the high values and then hit it hard. Now this particular song isn't showing a lot of impact. So let's pump that up by adding a little bit more here, plus 0.2. I like it like that. And let's do the same for this one. And we can add +2 here as well. And you can see we're getting something a little bit more pumping. I think we want to use even less, so I'm going to put this to this. So now we're only using the first 20th of the wave, but there's a lot of action there. So now one thing is it might be boring to go from bottom to top, so let's change that. Let's make a value that goes from the middle out. So what we're going to do is we're going to take V, which goes from 0 to 1, and let's subtract 0.5, right? So now it goes from 0.5 to positive 0.5, and let's take the absolute value of that, and let's multiply that by 2, so it goes from -1 to 1, and let's use that here. Now we're going from the middle out. I think symmetry is sometimes cool. So yeah, it's looking cool. Let's do the same thing for the other direction. SU. Now we have something symmetrical in all directions. So that's kind of interesting. I would probably prefer something a little bit more interesting, so we can go even crazier. There's a function called the arctangent, or atan. Since we have values that basically goes, 0 to 1 this way, right? 0 to -1 in y, or actually 0 to 1 this way, right? This would be negative x and positive y, negative y and negative x, positive x and positive y, blah, blah, blah. We can compute the angle that it's going around using the arctangent. So that would be arctangent. Hello. Oops, wrong side. So that would be, I don't know, let's call this angle u equals the absolute value of the arctangent of SU over SV, and arctangent goes from plus pi to minus pi. The absolute value make it go from from 0 to pi, and then we want to divide by pi to get a value from 0 to 1. So let's go define pi up here. Now let's use the radius we want. We'll call that SV. We'll make it the length, or the distance this thing is from the center. So we can do that by putting the two values into a vec2 and then using the length function. And let's change this to AU and AV, and now we have something that's kind of circular. I think that's pretty cool. Let's comment this sign stuff back in. We're getting something a little more colorful. Maybe we can use the sound instead of the time. That's pretty cool. I usually like it when I pick kind of just a range of hue, because the sound goes from 0 to 1, which means it'll take the hue all the way from red all the way through the whole rainbow. So I would probably try something more like this. That would only do 2 ranges of hues. And then I would probably add in the time. Time is maybe 0.1, so it's going to slowly use a range of hues as it goes across. Let's try some other things. Let's try setting this to the radius. So now it is unsaturated in the middle and saturated at the ends. I would prefer the opposite of that, so saturated in the middle and not saturated at the ends. Now here comes an example of a good function. Right here we've been doing some math. We know that AV goes from 0 to 1, or something close to it. And here, to go from 1 to 0, we just subtracted it from 1. But another way is to use the mix function. The mix function, you give it a starting value, you want to start at 1, you give it an ending value, and then you give it a value that goes from 0 to 1. When it's 0, it'll be this first value. When it's 1, it will be the second value. And when it's anything in between, it'll be a mix between those two. So now I can say I want it to go from 0 to 1, or I want it to go from 1 to 0, or maybe I want it to go from 1 to 2, right? since it's clamped, since the saturation is clamped, it's basically fully saturated, fully saturated, fully saturated till it's halfway out, and then we get a little bit of going to unsaturated on the edges. I'm going to leave it at that, but I'm going to set this to -10. You see we're only getting it in the middle. Another cool function I find is the step function. The step function is basically like a mini if. So we can go step 0.8 sound. What that says is if the sound is less than 0.8, then step returns 0. If it's greater than or equal to 0.8, step returns 1. So this basically gives us this interesting pattern where only if it's a hot sound does it get saturated. Otherwise it's completely unsaturated. Sometimes I like to pull it out, so I'm going to pull it out and call it pump. And I'm going to say pump equals that. I can change this to pump back here. Now I can use pump to mix. So I will say, right, kind of the same thing. When pump is 0, be this. When pump is 1, be that. Oop, not min, mix. And I'm going to do the same there. I'm going to say mix 1, pow, pump. So now it says, right, when it's under the pump value, which is 0.8, then take the value way down. Otherwise, use our previous value. So we're getting something really dynamic now. And I'm going to stop there. Now you've seen incorporating some sound into your example. I hope you liked it. Next up, we're going to start making a quad strip and doing stuff with circles instead of points. So join me for the next video.